All right, let's dive into something that's, well, running the show behind pretty much every single app you use. I'm talking about object-oriented programming, or OOP. We're going to break down how this way of thinking took coding from this chaotic mess of instructions and turned it into something way more elegant, something that actually mirrors the real world.
So, picture this. You've got to build a super complex app. Is that process kind of like trying to assemble IKEA furniture, but for an entire house with just one giant, never-ending instruction manual? A manual that's thousands of pages long? Just hang on to that thought for a second.
Okay, so to really appreciate just how revolutionary OOP was, we first got to look at the problem it was built to solve. Let's take a little trip back in time and check out the old way of doing things, something called procedural programming.
Remember that giant instruction manual we just talked about? Well, that's pretty much procedural programming in a nutshell. It's just one long list of steps. Now look, that's fine if you're building a simple bookshelf. But what about a massive software project? Imagine making one tiny mistake on page 2, and the whole structure is compromised. Finding and fixing that error would be an absolute nightmare.
And this is where you can really see the massive shift in thinking. On one side, you've got the old way, that one giant, overwhelming list of instructions. But on the other side, that's the OOP approach. It's a world filled with individual things, or objects, that all talk to each other. So instead of one single manual for the entire house, you get separate, manageable instructions for the door, for the window, for the walls. You get the idea.
So, how do we actually start thinking in objects? It really all boils down to two fundamental ideas. Two concepts that let us build a model of the real world right inside our code.
Okay, first up, we have the class. The easiest way to think about a class is as a blueprint. It's the design for a house or a car or maybe a door. The blueprint lays out all the properties it should have, like color or size, and all the things it should be able to do, like open and close. But here's the most important part. A class is just the design. You can't live in a house blueprint, right? You definitely can't drive a car blueprint.
So, if the class is our blueprint, then the object is the real thing, the actual thing you build from that blueprint. From just one door blueprint, or class, you can create a ton of unique door objects. Your front door might be a brown wooden door object, while the one to your bathroom is a white plastic door object. See? They both came from the same blueprint, but they are completely different real-world things.
Okay, so now we have our blueprints, our classes, and our real things, our objects. So what is it that makes this whole system so incredibly powerful and organized? Well, it all rests on 4 key principles, what everyone calls the 4 pillars of OOP.
First up, we have encapsulation. Just think of this as a digital safe box. Your data is inside, and it's protected. A perfect example is your bank account balance. That's super important data, right? You can't just stroll into the bank and change the number on a computer yourself. No way. You have to go through a proper channel, the bank teller. That teller is like a method in programming. Encapsulation is what bundles your data and the approved methods for changing it all together in one safe package, protecting it from anyone just messing with it.
Next up, we've got abstraction. And honestly, this is all about hiding the messy details. Think about sending a text message. You type your message, choose a friend, and hit send. That's it. You don't need to know anything about how your phone turns that text into radio waves or how it bounces off a cell tower. All that crazy, complex stuff is hidden away or abstracted. All you get is a simple button for a very complex machine.
Pillar number 3 is inheritance. And this one works pretty much exactly like a family tree. Let's say you have a general animal blueprint, a class, that has the ability to eat. Now, you can create a more specific dog class that inherits from the animal class. What's cool is the dog automatically knows how to eat without you writing any new code for it. Then you can add its own special behaviors, like bark. This creates what we call an is-a relationship. A dog is an animal, and this saves programmers a ton of time.
And that brings us to our final pillar, polymorphism. It's a Greek word that basically means many forms or many shapes. And all it means is that one single action can have totally different outcomes depending on the context. So if you issue a speak command, a dog object is going to bark, right? But that same exact speak command sent to a cat object will result in a meow. Same action, different results. That's polymorphism.
Okay, I know these ideas can feel a little theoretical.
So let's bring it all back down to earth. Let's connect these 4 pillars to something tangible, an app that I bet almost all of you have on your phone right now.
Think about a food delivery app. It's a perfect showcase for OOP. Every restaurant you scroll past, that's an object created from a restaurant class. A customer is just a special kind of user, so that's inheritance at play. Your list of past orders is kept private. You can only add a new one by using the Place New Order method. Boom, that's encapsulation. When you tap that big Place Order button, you don't see all the crazy logistics happening in the background. That's abstraction doing its job. And finally, maybe the app's calculate payment method works one way for a regular customer and another way for a pro customer, using the same command. And there's your polymorphism.
All right, so we've covered a lot of ground. What are the key takeaways here? Let's do a quick recap.
This little table here is a great way to lock it all in. Encapsulation, that's your digital safe box, all about hiding and protecting data. Abstraction, that's the TV remote. It's all about making things simple. Inheritance is your family tree, which lets you reuse code. And polymorphism is like one person playing many different roles. It gives your code serious flexibility.
So at the end of the day, OOP isn't just about writing lines of code. It's a much bigger idea. It's really a powerful philosophy for taming complexity. It lets us build these incredible pieces of software by modeling the world just as we see it, as a collection of individual things that all interact with each other.
So I'll leave you with a little challenge. The next time you're scrolling through any app on your phone, try to look past the shiny interface. See if you can spot the blueprints, the classes, working behind the scenes. Can you picture that world of objects all talking to each other just to make it all happen for you?